Chapter 3, Section 6, Factoring Trinomials. So we've talked about all of the factoring techniques except for the trinomials. And when we talk about factoring trinomials, we have two different types that we need to talk about. And the first one we're going to talk about is when your leading coefficient is 1. In other words, your x squared term doesn't have a number in front of it, which is understood to be 1. So when you see this trinomial, the first thing you're going to do, of course, is factor out anything that's in common. But if there's not anything in common, or if you've already factored out what's in common, then what you're going to do is you're going to open up two sets of parentheses and you're going to decide on your signs. And this chart will help you decide on your signs. These are the signs in your problem. So if you have a plus and a plus in your problem, like this, then your answer is going to have a plus and plus. If you have a minus and a plus in your problem, then your answer is going to be minus and minus. And if you have a negative and a negative in your problem, your answer is going to be negative and positive. And if you have a plus and minus in your problem, then your answer is going to have a negative and a positive. So one easy way to remember this chart is if the second sign is positive, then the two signs in your problem are going to be the same, and they're going to match the first sign. If the second sign is negative, then the two signs in your problem are going to be different. So once you have your two parentheses open and you've got your sign set, then what you're going to do is you're going to take the square root of the first term, which is just going to be a variable squared or to the even power. So you're going to take the square root of that and you're going to put it in the first set, spot of each parentheses. And then number 4 is probably going to be the hardest. What you're going to do is you're going to find things that you can multiply together to get C, which would be your last term, but add together to get B, which would be that middle term. And then you're going to place those in the last spots of the parentheses. So let's look at this. So the one on the left, what you're going to do is you're going to look for anything that's in common. There's not anything in common for all three terms. So we're going to open up two sets of parentheses. And since this second sign is positive, I know that the two signs in my parentheses are going to be the same, and they're going to match this first sign. So we're going to have a plus and a plus. The third step is to take the square root of your x squared term. So that's going to be x and x, and those goes in the first spots of the parentheses. And then what you're going to do is you're going to find things that you can multiply together to get 12, but add together to get 8. And so when you do this, I make this little chart because it just helps me see. It's what you can multiply together to get 12, but add together to get 8. So what you're going to do until you learn how to do this is you're going to list all the things that you can multiply together to get 12. So for example, you got 1 and 12, 2 and 6, and 3 and 4. So these are all the factor pairs that can multiply together to get 12. So when you list these out, you need to understand that only one pair will add up to 8, and that's going to be 2 and 6. And this will always be the case. There's going to be multiple pairs that will multiply together to give you that last number, but only one specific pair will add together to give you that middle number. And so that's factored x plus 2 times x plus 6. Okay, the problem on the right, there's nothing in common. So we'll open up two sets of parentheses. And since the second sign is positive, I know the two signs inside my parentheses are going to be the same. And they're going to be both negative. Alright, the next thing we're going to do is we're going to take the square root of x squared, which is going to be x and x. And then we're going to see what we can multiply together to get that last number of 24, but add together to get negative 10. So again, list the factors of 24. We have 1 and 24. 2 and 12, 3 and 8, 4 and 6. So like I said, you list all of those factors, but only one factor pair will work, and it's going to be the 4 and the 6. So we have a negative 4 and a negative 4 and a negative 6. Alright, the last problem on the bottom, we're going to open up two sets of parentheses. And since this second sign is negative, then I know that the two signs are going to be different. So there's going to be a plus in one and a minus in the other, and it doesn't matter which is which. If you wanted to put the plus first and then the minus first and the plus second, that would be fine. So the signs are going to be different, and you're going to split that x squared into x and x. And then we have to think, what can we multiply together to get 30, but add together to get 7? So let's list all the factors of negative 30. And there's going to be a bunch because the signs are different. So we're going to list negative 1 and positive 30. And then we have 1 and negative 30. We have 2 and negative 15. And negative 2 and 15. We have 3 and negative 10. And negative 3 and positive 10. And then we have 5 and negative 6. And negative 5 and positive 6. Okay, so this is everything that I can multiply together to get negative 30, but only one factor pair will add together to give me a positive 7. And I think it's going to be the negative 3 and the positive 10. So the 3 has to go with the minus sign, and the 10 has to go with the plus sign. A little hint here, the biggest number needs to carry this sign. So that's why 10 is going to be positive. Okay, the next type that we're going to talk about is when your trinomial, the leading coefficient of your trinomial is not 1. So, for example, you see this a here. That means that your leading coefficient is actually going to be a number aside from 1. So it could be like a 2, a 3, a 10, whatever. When you have a trinomial and your leading coefficient is not 1, there's many ways to factor this. There is the bottoms up, which is what I'm going to teach. There's guess check, AC method. There's all kinds of things that you could have heard of on factoring these. And if you know a technique, then by all means do it. You don't have to do bottoms up if you know another technique. But if you don't know another technique, then I would suggest that you learn how to do bottoms up. So to do bottoms up, if you can remember, my father drinks Red Bull, you can remember the steps. And there are 5 steps to do in bottoms up. So the first one we're going to do is multiply. So we're going to multiply A times C. Now what does that mean? Well, if you look back at your general form, you'll see A times C. So we're going to multiply A times C and make a new trinomial with a leading coefficient 1. And that last term is going to be what you got when you multiplied A times C. So let's look at this problem and try that. So the very first step is to multiply 6 times negative 20. So what we're going to do is we're going to have a new trinomial where your leading coefficient is 1, because we're taking the 6 into the negative 20. And you're going to get negative 120. So the multiplication is taken care of. The next thing you're going to do is you're going to factor that new trinomial. So you have a trinomial where your leading coefficient's 1. We just learned how to do that. Open up 2 sets of parentheses. Your signs are going to be different, and I know that because the second sign is negative. This sign here. And then what we're going to do is we're going to split this x squared into x times x. And we're going to think, what can we multiply together to get a negative 120, but add together to get 19. Now, there's going to be a lot of factors of negative 120, and so I kind of want you to get accustomed to what we're doing. If you list a factor of something like negative 1 and 120, you know that there's no way that that's going to be even close to 19. So what I want you to do is I want you to take 120 and I want you to just start dividing by numbers. And to me, 10 would be an obvious one. So if we do negative 10 and 12. Negative 10 and 12, there's no way that that's going to give us 19 either. No matter which way we go, we're going to get either a 2 or a negative 2. So let's try again. Let's do 120 divided by 8. So if we do a negative 8 and a positive 15. Negative 8 and positive 15, that's not going to give us 19 either, but we're getting a little bit closer. So let's try, okay, so let's try 24 and 5. So 120 divided by 5 is going to give you the 24. So we have 5 and negative 24, or we have a negative 5 and a positive 24. So if you think about it, this negative 5 and positive 24 is going to give us that 19. So we'll have the 24 to go with the plus sign and the negative 5 here. Now, a lot of people make the mistake and they stop here because you have factoring on the brain and we just factored, so you think, well, we're done. Well, that's not the case, because this is not the problem that we're trying to factor. This original one is the problem that we're trying to factor. And if you multiplied this back out, you're going to get this one, not the one that you started with. So there are some more steps. Remember, there's 5 steps and you're not finished until you do all 5. We've only done 2. So the third step is to divide the constant by the original, a. So we're going to divide 24 and 5 by our original number that we multiplied in. So we multiplied 6 in, so we need to turn around and divide 6 back out to balance things back up. And then R stands to reduce our fractions. So we're going to reduce 24 over 6 to 4. And 5 over 6 will not reduce, and that's okay, because our very last step is if you have a denominator, if you have a fraction that won't reduce to a whole number, then that's where this name comes from. You're going to bring the bottom up. So for example, in the first group you have x plus 4, but in the second group we're going to bring the 6 up, so we'll have 6x minus 5, and that is your answer. Alright, so let's try again. We have a trinomial. Our leading coefficient is 10. And there's nothing that we can factor out. There's nothing in common. So what we're going to do is we're going to multiply the 10 into the 3. And so we're going to have x squared minus 17x plus 30. Alright, so let's factor this. So our signs are going to be negative and negative, and we're going to split the x squared into x and x. So we have to think, what can we multiply together to get 30, but add together to get a negative 17? And again, you can do a little bit of forethinking. You know that negative 1 and negative 30 is not going to give it to you. So negative 5 and negative 6 is not going to give it to you. What about negative 2 and negative 15? So you can see, again, a lot of factors, but only 2 of them will work. So we'll put 2 and 15 because that's going to give us that negative 17. Don't stop there. Remember, my father drinks Red Bull. So we multiplied and we factored, but you still have 3 more steps. So we multiplied a 10 in the first step, so we're going to divide out a 10 in this third step. And then we're going to reduce. So we'll have x minus 1/5 and x minus 3/2. Okay, so we reduced our fractions, and now both of these are still fractions, so we need to bring the bottom, the denominator, up front. So we have 5x minus 1 and 2x minus 3. Okay, the problem on the right, it's a trinomial. My leading coefficient is not 1, and there's nothing in common. Remember, you need to check all of those. So what I'm going to do is I'm going to multiply the 4 into the 27 and get 108. So we have n to the 4th plus 3n squared minus 108. Alright, so let's factor this new trinomial. The signs are going to be different, and we're going to split that n to the 4th into n squared and n squared. And then we have to think, what can we multiply together to get negative 108, but add together to get 3? So let's start working on that. If we say 108 divided by, I don't know, 3, we get 3 and 36, so you know that's not going to give us 3 at all. But if we do 108 divided by 12, we get 12 and 9. So that's going to be our numbers, 108 divided by 12. So if we do a positive 12 and a negative 9, those are going to be the magic numbers. Again, there's a lot of numbers that you can check, but only 2 of them will work. So the 12 is going to go here, and the 9 is going to go here with this negative sign. Okay, so we multiplied the 4 in. Now what we need to do is we need to divide the 4 back out. And then we're going to reduce, so we're going to have n squared plus 3 and n squared, and this won't reduce at all, so we're just going to leave it as is, and then we'll bring bottoms up. So we have n squared plus 3 times 4n squared minus 9. Now, the directions on your test, remember, are going to say factor completely. So 4n squared minus 9, if you'll notice, that's one of those patterns that we talked about. We talked about the difference of two squares. This first grouping, this first binomial, it's prime. You can't factor that. But that second binomial is the difference of two squares. And it will factor into a sum and difference. And the square root of 4n squared is going to be 2n. And the square root of 9 is going to be 3. So now it's factored completely. Alright, so the problem on the left, again, we have a trinomial, there's nothing in common. The leading coefficient is not 1, so we need to multiply it into the 15. So we'll have x squared minus x minus 30. And then we need to factor this trinomial. Signs are going to be different. Split the x squared into x, and let's think, what can we multiply together to get negative 30, but add together to get negative 1. And again, you can go through the factors if you need to, but I'm going to go ahead and say that that's going to be a negative 6 and a positive 5. So the 5 will go here, and the 6 will go here. But don't forget that that's not the full factoring, so we have to divide back out the number that we multiplied in. So we're going to divide by 2. And then reduce. 5 halves will not reduce, but 6 over 2 will reduce to 3. And then bring the bottom up, so we'll have 2x plus 5 times x minus 3. Okay, the problem on the right, it's a trinomial. My leading coefficient is not 1, but there is a 2 in common. So we're going to bring a 2 out here. And so we'll have 10x squared minus 23x plus 12. And then what's left over is a trinomial where the leading coefficient's not 1, and this is where we'll do the bottoms up. So we're going to multiply the 10 into the 12. And it's important that we remember that, so that in step 3 we remember to divide that 10 back out. So we'll have x squared minus 23x plus 120. Alright, so now let's factor this trinomial. And so the signs are going to be the same. They're both going to be negative. And we're going to split x squared into x, and we're going to think, what can we multiply together to get 120? But add together to get a negative 23. And I think we said it a while ago, 120 divided by 5. No, 120 divided by 15. Yeah, 15 and 8, and they're both negative, so that will give us that negative 23. So we have a negative 15 and a negative 8. Now, we're going to divide the 10 back out. Not the 20, because remember we factored out a 2, so the 10 is what we're going to divide back out. So we're going to have 2 times x minus, and we're going to reduce this, so this is going to be 3 halves, times x minus, and then 8 over 10 is going to reduce to 4/5. And then we finish up by bringing the bottoms up, so we have 2x minus 3 and 5x minus 4. Okay, the last thing we're going to talk about is multiple variable factoring. To factor polynomials with multiple variables, you're going to use the same processes, the same techniques that we've already learned. You're just going to have to keep up with those extra variables. So for example, the problem on the left, this is the difference of two perfect squares. So remember your process. You're going to open up 2 sets of parentheses. Signs are going to be different. Square root of p to the 4th is p squared. And the square root of 81q to the 4th is 9q squared. And remember, it's going to say factor completely. So the sum of two squares, this first one, it is prime. But the second one, that's the difference of two squares again. So we can factor that again. So p squared is going to factor into p times p, and then 9q squared is going to factor into 3q. And then the one on the right, this one is, there is something in common actually. There's a 3. So if we take a 3 out, we're going to have 2x squared plus 5xy plus 3y squared. And then inside there we have a trinomial. The leading coefficient is not 1, so we're going to use bottoms up. So we're going to multiply the 2 into the 3, and so we'll have x squared plus 5xy plus 6y squared. And then we're going to factor this new trinomial. Signs are going to be the same. So we're going to split this x squared into x and x. And what can we multiply together to get 6, but add together to get 5? And that's going to be the 3 and the 2. But we have to throw in this y squared, so we have 3y and 2y. Now we're going to divide a 2 back out, because we multiplied a 2 in initially. So we'll have 3 times, this won't reduce, plus 3 halves y. And then this one will reduce, so we'll have x plus y. And then bottoms up, so we'll have 3 times 2x plus 3y times x plus y. Alright, last 2 problems. The one on the left, this is your perfect square trinomial. There's nothing in common. And remember, a perfect square trinomial will go to a binomial squared. You're going to match that first sign, so it is going to be plus. And the square root of 9a squared is going to be 3a. And the square root of 25b squared is going to be 5b. And you're done. And then the problem on the right, there is a 2 in common. There is at least p to the 4th in common and at least a q squared in common. So if I divide each one of these by that common factor, for the first one we'll get 5p squared plus, for the middle one we'll get 2p q, and for the last one we're going to get just a q squared. And then inside we have a trinomial, but it won't factor, because if you try, you're going to have to think of things that you can multiply together to get 5, but add together to get 2, and there is nothing, so that's not possible. Alright, so this is probably one of the toughest things that we've done, so I'd like for you to complete these problems on page 165, and if you have any problems, then bring them into class.